Good morning, everybody. Can everyone hear me right at the back? Yay, awesome. Well, thank you all for coming. I know there are several other very interesting talks on at the same time, so it's really nice to see so many people here. Who was here for Jamie's keynote just before? Lots of people. Well, I thought it was a great talk. I'm also very grateful to Jamie because after that, there's absolutely no danger of me appearing to be too political or or immoderate in any of the things that I might say. So that's very helpful to start with. Okay, before I get going, can I have a quick show of hands in the room? Who has heard of Typelevel? That's most people. Who hasn't heard of Typelevel? Just to sort of, not very many people. Of the people who have heard of Typelevel, who thinks that it's basically just a bunch of open source projects, and who thinks that maybe there are some other things going on there as well? So a few people. So most people basically think it's just a label for a collection of open source projects. That's kind of what I would have expected. Okay, well it's got a logo now. This is the Typelevel bouncy turnstile, I think, is the name that Rob Norris gave it. It's a really, I think, kind of quite a nice little thing. It's a riff on, it's sort of, if you squinted it one way, it's a T for Typelevel. If you squinted it another way, it's a sort of a staircase. If you squinted it the way head-on, it's kind of the sort of capital T turned on its side, which is a semantic or syntactic turnstile, which is an operator which is used in sort of type theory and logic and things like that, which is really nice. And I hadn't actually realized it, but if you sort of rotate it about sort of 30 degrees, you also get a little lambda in there, which is also kind of nice. So it's something for everybody. Let me just move my mouse pointer out of the way. Okay, so what is Typelevel? So it's a community of projects and individuals organized around pure, typeful, functional programming in Scala. To unpack that a little bit, by pure, what we mean is that we want to program without uncontrolled effects. We want to treat our functions as functions in the mathematical sense, and we want our programs to have the property of referential transparency, something that you will hear people talking about a lot. But basically, which means that you can reason about programs by making simple substitutions without having to be concerned about how a substitution of equal things might somehow, in some unpredictable way, change meaning. By typeful, we mean that we want to make as much use as possible of Scala's very expressive type system to allow us to express properties about our programs, to allow the compiler to verify those properties, to allow the compiler to use our descriptions of characteristics of our programs to help us construct our programs. So types are unsurprisingly, I suppose, for an umbrella group called Typelevel, types are something which are very important to us. Functional programming, I suppose by the time we've had pure and typeful, we basically have functional programming. We're programming with functions. But the key thing is the last bit, in Scala. So one of the things we want to do is all of these things, but idiomatically for Scala. Whilst many of the ideas that projects within the Typelevel family, whilst many of the projects within the Typelevel family draw inspiration from other programming language communities, be it sort of Haskell is a sort of common sort of touchstone for people working in the Typelevel space, or maybe even more exciting languages like Agda or Idris. The key thing is we want to bring things back into Scala in a way which is idiomatic, which cuts with the grain of the language, which isn't just trying to be Haskell or Idris fanfic. It's got to be something which actually works as Scala code, either within the confines of the language as it currently is, or at least in principle, as it could be, where we've got some kind of reasonable prospect of actually making the language fit what it is that we want. So that's the kind of the sort of, if you like, the sort of technical philosophy, I suppose, behind what Typelevel is. In terms of the actual organizational structure, it's a collection of independent, free and open source software projects. It's pretty much the case that, well, it is the case that every single constituent project of the organization as a whole is an open source project with a free software license of some form. Independent in the sense that, well, in multiple senses, in the sense, firstly, that most of the projects they are community projects. They're not backed by any particular organization or commercial entity. They're independent in the sense that the whole organization itself is bottom-up. Typelevel exists because of its constituent organizations rather than because of some sort of hierarchical structure. It's a bottom-up organization. Sort of more into if you like, the non-technical aspects of it, we've got a desire to share ideas and share code. We want our stuff to be accessible and easy for people to understand, easy for people to draw on. We want people to be able to sort of, even if not directly use our projects, at least draw inspiration from the way they're structured, and to treat them as a model for kind of best practices for how code in this style can best be constructed. Obviously, with the proviso that we recognize that there are other styles and there are other ways of doing things, and one size doesn't fit all. Sharing ideas is one thing, sharing code is another. One problem that we often have in the Scala community is that it's actually quite difficult sometimes to have binary dependencies on other projects because of some of our kind of unfortunate bumps in the road on our kind of binary compatibility story. And one of the things that the Typelevel project in aggregate want to be able to do is I'm not saying we're necessarily able to actually succeed at this, but at least be very, very aware of the fact that people will want to use our projects both together with each other and in conjunction with other pieces of software and across multiple versions of the Scala programming language. So one of the things we would really love to be able to try and avoid is the situation where people feel obliged to absolutely minimize their dependencies because every dependency they have, they know will at some point come and bite them. We want to try and get to a situation where that is not anything like as much of a problem as it has been in the past. We want to be approachable and clearly sharing ideas and sharing code is only going to work if people actually can understand what we're doing. And to do that, we need to be able to provide people both in the community and people come into the community with resources that will help them get inside to understand what that first line of pure typeful functional programming really means and appreciate it and understand why that matters and why it's important. And for that, we need to have accessible learning resources. We need to have also an environment and a community of people who actively want to reach out, generally bring people in and meet people on their own terms rather than sort of dictate terms to them from some position on high, because I don't think that's productive or helpful. So that's kind of, if you like, the winding back. Eric Osheim, who's one of the co-founders of Typelevel, he did a fantastic talk on building open source communities last year at Scala World in the Lake District in the UK. And I highly recommend that people find the video of that and watch it. It's a great talk, and I think very much elaborates on this kind of picture of what Typelevel is as a thing. Okay, so this is the way in. Top level is typelevel.org. Basically, because it's a community of software communities, I guess. And where do open source software communities live these days? They live on GitHub. So basically, everything is organized around a Typelevel organization on GitHub, under which you will find a Typelevel general project. That's basically where all of our kind of, if you like, business stuff happens, where we discuss how we're going to organize, how we're going to set up events, and general kind of matters of policy and all that kind of stuff. There is also a type-level Gitter channel corresponding directly to that repo. It's a very, very lively Gitter channel. I highly recommend that people join it, and that's where we basically talk about what we're doing. Just as a general thing, in principle, pretty much all of the type-level projects have, I would say more or less en masse, moved from IRC to Gitter. I think we found it to be a much better environment for discussions around software. And there are now some extremely lively Gitter channels associated with different type-level projects. Cats is one of them. That has about 800 or 900 members of the Gitter channel. The Shapeless channel is, I think, the second biggest one with about 600 or 700 or something like that. So very, very busy, lively communities. Much bigger than the corresponding IRC channels were. Okay, whoops. No. Fast. Right, okay. So type level is, I said back at the beginning, I said it was a community of projects and people organized around pure typeful functional programming. So it's community projects. What are the projects? So there's a whole bunch of libraries. Who here has heard of Cats? Yeah, lots of people. Shapeless? Yeah, lots of people. Okay, so I guess this is a crowd where most of these libraries are familiar in one way or another. Is there anything on this list that people are surprised is actually a type-level project? That maybe a project that's very familiar to them that they've used but didn't realize it was a type-level project. I suppose that's a hard question to ask an audience. But anyway, so we've got cats, alley cats, kittens, and dogs. So cats is fundamental data structure and type classes. Alley cats are kind of fundamental type classes which are slightly dubious for various reasons, which are somewhat controversial. Kittens is a library of mine which uses shapeless in conjunction with cats to automatically derive type class instances for cats. Dogs, cats and dogs, could that go wrong? I don't know. Dogs is a library of functional data structures. So cats itself is a library of type classes only. It has very few actual concrete data structures. Shapeless is my generic programming library. Refined is a library which is uses shapeless in part, but basically elaborates on those ideas massively to take us in the direction of dependently typed programming via refinement types. Spire and Algebra, they're both mathematical libraries. I think Spire is kind of the almost de facto numerical library for Scala now. Algebra is a set of related type classes and structures for mathematical algebraic kind of characteristics. Monocle is I think most people agree is the best of breed lens library for Scala. So scodec and Circe, scodec binary serialization, deserialization framework, Circe JSON serialization, deserialization, both of them working with shapeless to provide automatic generation of instances for arbitrary algebraic data types. And doobie, a type-safe JDBC layer. So within this group of standalone libraries, there are many dependencies and interrelations which we think are very desirable. We don't want everybody to be reinventing the wheel. So Cats is, we'll see a little bit more about Cats later on, but Cats is in aggregate quite a large library, but we've managed to work out a sensible way of producing, if you like, submodules which represent core and even smaller kernel characteristics, which can be very, very easily shared between other libraries. In particular, the algebra library depends on the Cats kernel. Cats kernel contains basically the minimal, functor, etc. type classes that you want to have in almost any circumstances. And algebra being the foundation for a number of commercial projects and things like Algebra and such like, needs to be very, very solid and very, very stable. So for it to have a dependency on Cats kernel has to have some kind of commitment to being something that will be very stable and something that can be relied on as a dependency. Several of these libraries depend on shapeless in one way or another. There is just a general desire for all of these projects to work together and to collaborate and to make great things, not individually, but as part of a team. Okay, other things which, beyond standalone libraries, Enzyme is part of Typelevel. Toot is a, sorry, for people who don't know, maybe there aren't any, but Enzyme is cross-editor tooling for Scala, so it will provide Scala language capabilities for Emacs primarily, I suppose, but also for Vim, for Sublime, and I'm not sure what others, but I guess those are the main three. Toot is a library for writing, is a tool for providing type-checked documentation. So going back to one of the goals of producing accessible, up-to-date, accurate documentation, having documentation which is both readable and also guaranteed to be checked against the libraries, the code that it's intended to be describing is a really important thing. Disciplines is for checking laws. Type classes have to satisfy various kinds of properties, and we need to have mechanisms for verifying that those things are true. ScalaCheck, I'm sure lots of people have heard of ScalaCheck. Maybe it's not quite so well known that ScalaCheck is part of Typelevel. Also Specs 2, again, very well-known testing framework. And Catalyst, finally, is some sort of common shared build infrastructure, very much a work in progress, but it's a mixture of build infrastructure, both at the level of infrastructure that can be shared as part of an SBT build by different projects, but also one of the things we're aiming in the direction of, and exactly when we'll get there is not quite clear, but providing some kind of mechanism whereby we can do the kind of the equivalent of a community build, but if you like a type level community build to demonstrate that our projects do actually build together and interoperate nicely. Bunch of integrations. Mostly these are things that sit on top of shapeless, because if you can derive type classes for arbitrary ADTs, then there are a whole bunch of libraries that can make use of that. So various things have appeared in that department. And then we've got a bunch of things that are, I mentioned earlier on that we were trying to do things which are idiomatic within the Scala language. There are some things where Scala is almost there, but not quite, and we need to do a few little bits extra that will take us slightly outside of the language to make the kind of code that we're writing either easier or perhaps possible to write. And for the most part, over the last year or so, the mechanism we've used for that has been primarily macros. So, for example, the macros in shapeless. Or plugins. An example of that would be the Kind Projector plugin, which is used quite heavily in Cats. Both of these things are either to sort of, if you like, extend the syntax, extend the scope of what is expressible in Scala source code without fundamentally changing the language. But things which provide enormous benefits for people writing software in the kinds of styles that we do. There's a whole flurry of activity around simulacrum, machinist, export hook, imp, and local implicits. These are basically five macro-based libraries, which all of them aim to make the writing of and the use of type classes feel more idiomatic and feel less stricken with boilerplates than they might do otherwise. Currently, there is some work going on trying to talk about sort of maybe fusing all five of those libraries into a single sort of catch-all type class support, either compiler plugin or macro library, or possibly other things which I'll come back to later on. Macro Compat is a library that I put together trying to factor out some of the differences between Scala 2.10 and 2.11 to support all of these macro-based components. Plenty of new arrivals. So this, I last gave a sort of an update on Typelevel at Scala Exchange in December last year. So it's just over 6 months. So we've got a bunch of new projects which have joined. And so Finch is a project based, so it's a kind of HTTP framework, as is HTTP4S. That's based on, completely lost what it's based on. But anyway, two very solid quality HTTP frameworks, at least. I'm sure at least some of you are familiar with them. Monix is a new arrival. It's basically again another I/O framework within the context of pure functional programming, so something which allows us to control I/O effects. Squants is a library providing typed quantities for Scala. There have been a number around. This is a particularly, I think, interesting one, something that's well worth taking a look at. Frameless is a relatively new arrival. This is something that's initiated by Adalbert Chang of Box. So this is making use of shapeless to provide a little bit of, well, I was going to say a little bit more, but some type safety to Spark. So basically, it's a kind of a data frame for Spark, which uses shapeless under the hood to preserve and make types useful in that context. It's very early days for that, but it looks really interesting. Matryoshka is kind of, it's a really fascinating library of sort of factoring out many of the different kinds of recursion patterns you find in functional programs. It's if you like, it's the sort of the kind of the ivory tower annex, I guess, of Cats. It captures a number of things which are very, very interesting, but at least in some contexts, maybe a little bit too high a level of abstraction for some people. FCats is another project in the mold of trying to capture and control effects in one way or another. This is from Eric Toribor. There are a couple of other things in that kind of general area around as well. And Delta is a really nice project. It's kind of young, and it's another thing which is built on top of shapeless, and it allows you to compute arbitrary differences between values of algebraic data types, which is kind of interesting. So you might have, I don't know, some algebraic data type that represents some kind of customer or product record, and you might want to be able to work out what is the difference between two instances of those things, and do it in a way which is sensitive to the types of the elements in that data structure, and that's something that Delta will do. It's a very interesting library. So all of these different projects, we have there is a sort of a theme. There's a sort of a type level hexagon. And there are a number of projects now which have kind of logos and stickers which play on that theme. We've got a type level logo. There's a new shapeless logo, and an ensign one as well. I'd love to say that you could go outside and get stickers for your own laptops, but there were a whole ton of them on the 47 degrees stand yesterday and the day before. They've all gone, so I'm afraid it's too late. Yes, so. When Lars posted that photograph of the stickers arriving, Ed Kmet, the kind of Haskell guy, kind of posted this. I actually have no ideas what the Settlers of Catan actually is, but apparently I've been told many of you will know what that is. But anyway, that's apparently the way that it pans out. That is the back of my laptop there. So that was community projects, but well, actually, no, there's one that's sort of conspicuously absent, and that's Typelevel Scala. So where is Typelevel Scala in all of this? I'm going to come back to that later. So as well as community projects, it's a community of people. And this is something that's been new this year. This is something that we kicked off at the very end of last year, sort of starting organizing stuff. But we felt that it was really, really important to not just be kind of just a bunch of GitHub repositories, but we actually wanted to have some kind of context in which we could basically get together, talk, discuss, hack together, and with that in mind, we have organized so far this year 2 events, both of them attached to existing conferences, both which have sort of strong associations with Typelevel. That's Scala, which this year was in Philadelphia, and FlatMap, which is in Oslo. Many of the sort of the pivotal kind of events in Typelevel's history have kind of happened at those conferences. So I think the existence that Typelevel was first announced, I think, by Lars Huppel at Scala. I think only 2 years ago. It seems like a lot longer than that, but anyway. And various discussions around Typelevel have happened at FlatMap when various of the projects initiators have been gathered together at those conferences. And they're great conferences. I mean, they are the community conferences. They have more of a kind of a meetup feel than kind of the big sort of the big enterprise conferences, and it's felt like a kind of a good natural association to have type-level events attached to them. So as far as the Philadelphia Type-Level Summit, we had the 2 days before the event was a 2-day type-level event with a day of invited talks and a day of unconference. Then we had an event in Oslo, and that was a day of invited talks. We only had 1 day for Oslo. It was both absolutely fantastic events. We've also, in the last couple of months, there was a fantastic event run by Salesforce in the UK. They have an amazing building right next to Liverpool Street Station in London. Basically, they make it available for all comers on a monthly basis for all-day developer events, completely free of charge. It's absolutely wonderful. And there has been a long-running event called Hack the Tower. It's primarily it's actually almost exclusively a JVM-based event. So there are people who are there who are Clojure people, OpenJDK people. The Ensign people have been going there for quite some time. And for the last couple of months, we've been running a type-level hack day event at Hack the Tower. This is something that we're going to continue. It's going to be a regular event from now on in London. Just want a quick thank you to all of the sponsors that made those events possible, which has been really, really awesome. So, upcoming events. So not just, this is not all flash in the pan. We want to have more of these things. So there's going to be a type-level day, unconference day at Scala World, which is coming up in September. There's been a long-standing kind of type-level track, I guess, at Scala I/O in France. And this time we're kind of making it sort of an official kind of type-level track as part of Scala I/O this year. There's going to be a workshop day at Lambda World in Cadiz. That's very kindly sponsored by 47 Degrees. We're also going to be having an event at Scala by the Bay in San Francisco. And there's going to be a hack/unconference day after Scala Exchange in London in December. So there's lots of stuff coming up. And we want more. So if you are an organizer of a conference or an event, and you think that the people that you attract to your conference will be interested in having type-level events, please do get in touch. We want to have more of these things happening all the time. So the type-level Hack the Tower days, they're ongoing. They're basically Saturday, mid-month, regular as clockwork is the intention. Aside from getting the chance to sort of hack on various things like the type-level libraries, Ensign, hacking on the Scarlet Compiler. There's more introductory stuff as well, but also, I guess, an absolutely fantastic view. It's really, really quite amazing. It's on the 28th floor, and you do get a really incredible view over London, so it's well worth coming if you're in the area. We would be really, really keen for user groups, meetup groups, if they wanted to organize events of this sort as well. We would love them to do that, and we'd love to coordinate with them on helping them make that possible. Okay, so I just want to give a quick update on 2 projects, and then take some questions. Very, very briefly. So Cats has a fantastic logo itself. This one by Eric Osheim himself, who's in his spare time, although I don't know how he finds any spare time, he writes indie games, and is pretty good when it comes to 8-bit art, which I think is great. So Cats, I think probably most people know, it's a library of abstractions for functional programming in Scala. It started at the beginning of 2015 by Eric. It's now reached over 2,000 commits and has nearly 100 contributors, which I think is an amazing achievement in that space of time. Very much an emphasis on approachability as much as technical merit. And I guess all of the kinds of things I was talking about in terms of dependencies and the ability to rely on a kernel, a core that people can comfortably depend on without having to be concerned about binary compatibility issues and such like, or churn, version churn is very, very key. So it's nearing a 1.0 release. It's no longer tagged as experimental. There's a growing body of documentation of other resources. The Cats Gitter channel is incredibly lively. It's a fantastic place to talk to people. It's a fantastic place to learn about functional programming. Recommend that everybody joins it. The one piece of sort of missing piece that has sort of prevented people from actually really seriously using it, or perhaps not prevented them, but made it harder, is that we haven't until recently had any kind of a sort of well-worked-out story about how to handle effects well. So we've had a really good story for pure functional data structures, but effects hasn't been something that's been part of our picture. We do now have, not as part of Cats itself, but as part of the Typelevel family and I guess kind of associates. We have Monix, which is able to provide a task abstraction, and also FS2. FS2 is not part of Typelevel. However, FS2 is an evolution of Scala Z Stream, which is sort of now independent from Scala Z, but it does have integrations. It has an integration for Scala Z. It also has an integration for Cats. So at this point, I think there are basically two ways that you can go if you're looking for mechanisms to manage effects. In a Scala functional programming context, you could look at Monix. Monix, I guess its distinctive feature at the moment is that it's Scala.js friendly. This is one of the things that many of the Typelevel projects have gone to fairly great lengths to do is to try and make sure that we are compatible with, that we produce builds for Scala.js as well as Scala JVM. Monix is able to abstract over the massive differences in terms of underlying runtimes between the JVM and JS to provide a kind of a task story that works across both. FS2, obviously, it's a very different kind of library. It does represent some kind of a transition path from the Scala Z task, and I think it's probably fair to say that it's currently the best solution for JVM only. This is an evolving situation. I expect both of those libraries to develop over time. I know that there is some enthusiasm on the part of the FS2 people to make their story work on Scala.js as well. I hope that happens at some point. So a lot of the things that we've been doing have kind of sort of pushed us up against some of the limitations of Scala as it is now. And this has... so one of the things we actually originally intended to do in Typelevel Scala, which is the thing I deferred from earlier on, was kind of pick up some of that slack. So it was... the sort of fork was initiated at the end of 2014, so that's quite a while ago now. And really, the intention was to make, if you like, minimal changes to the Scala programming language, which is ideally maximally kind of binary compatible with the Scala compiler that TypeSafe then, Lightbend now, are producing. But things which are going to help people programming in a Typelevel style to kind of do stuff more easily. And more easily doesn't mean, it's nice for library developers who like playing around with dependent types. It also means that it's nice for end users of these libraries, because if you don't have these kind of facilities intrinsically in the language, not having them doesn't make the problems go away. What will actually happen is that people will end up coming up with various kinds of workarounds or encodings of features which could be language-level features. And these inevitably end up being somewhat leaky, somewhat creaky, and they impose additional both conceptual and just implementation complexity on end users of libraries. So it hurts everybody if we don't have these things. So, so that was the aim of the Typelevel Scala fork. That completely stalled at the beginning of 2015. Most people are probably aware of the fact that prior to 2015, Scala Z was part of Typelevel, and there was a somewhat uncomfortable rift between Scala Z and the rest of Typelevel. That basically prompted the work on Cats, and as I said earlier, we've had since the initiation of Cats have been several thousand commits, 96 contributors. Basically everybody. Basically, everybody basically everybody who would have been working on Typelevel Scala was completely preoccupied with working on cats. So nothing happened at all. And like I said, the problems didn't go away, but rather than working on a full-blown fork of the Scala compiler, we ended up producing these sort of rather smaller, more modest sort of macro and plugin-based sort of band-aids for some of the problems. And we found actually that in practice, in many of these cases, they actually work quite well. And it made us sort of rethink what it was we were really trying to achieve with Typelevel Scala. And I think that was probably a useful sort of breathing space to sort of try and sort of reevaluate, just exactly what kind of value are we expecting to kind of bring to the table by forking the Scala compiler. There are a bunch of, there were a number of significant, there were a number of changes made in Typelevel Scala relative to the type-safe Scala compiler. Some of them were really interesting, and I'll mention some of them in a second. But some of them were really, really trivial. So, I mean, the first thing I did was to make a very, very tiny modification to the Scala parser to allow you to have a little prime at the end of identifiers, which, if you see much sort of Haskell tutorial code, you will often see some definition, sort of, x prime, and so on, through a series of definitions as you kind of unfold some kind of expression. And it's kind of nice to have, and it would be really nice to have, but honestly, it's completely trivial. And there is really no, in my opinion, justification for forking a programming language simply for something like that. So we decided to focus more on things that really matters, things that really, that would actually really make a difference, and that didn't really have any alternatives other than, at best, clunky workarounds. So the fundamental issues were there, and that was kind of the situation until sort of early this year. I kind of stuck my neck out in January and said that, publicly announced that I was going to deal with SI 2712 this year. Who knows what SI 2712 is? Can I have a quick show of hands? So, small number of people. I'm not going to go into any of the details. SI 2712 is basically, it's a tricky problem that affects type inference in Scala programs which make heavy use of higher-kinded type. So if you're abstracting over type constructors, then you will at some point inevitably be hit by SI 2712. There's a talk I did at FlatMap a few months ago, which if you want to know more about that, I recommend you go and have a look at that. There's also a very, very good article by Daniel Spiewak, who explains exactly what the nature of the problem is also very, very clearly. So I recommend that. So, but this is a long-standing problem. It's something that's been sitting in the Scala issue tracker for years, I think since 2009. If we could actually come up with a solution to this, it really would massively improve the lives of everybody working on type-level style libraries and also the users of those libraries. So it feels like it's the kind of thing that there are workarounds. The workarounds for it are things like unapply, if you've run across that in Cats or Scala Z, and the various kind of u-suffixed methods which sort of sneak unapplies in to otherwise straightforward methods. I guess unapply is sort of the type-level project equivalent of can build from, I guess, to give you some idea of why it's a necessary evil, I suppose. So wouldn't it be so much better if we could fix it? So I was going to be doing a talk at FlatMap on yet another workaround for SI 2712 that I'd come up with in the context of working on kittens, and was kind of idly reflecting on how we'd sort of given up on type-level Scala and we're looking at doing things in terms of plugins and macros instead. And I sort of kind of idly thought, well, is it possible that we could maybe fix a big problem like this in a macro or plugin? And of course, the advantage to doing it in this way is that this is something which doesn't depend on a future release of a Scala compiler or a massive language change. It's something that you can use with your existing Scala compiler. You just add it to your build, and hey presto, some magic happens, and you suddenly have enter a new world without taking on any dangerous, scary dependencies. And I know for some people, maybe there is actually practically very little difference, but for some people, adding a plugin to their build is nothing like as big a deal as switching to a completely different compiler version from some unknown random bunch of people. Okay, so I was idly thinking about doing this as I was going to present a talk on my new workaround for SI2712, and I thought at the end of the talk I'd present, some kind of discussion for what are the future possibilities, what might we do to fix this problem properly. And so I was thinking, well, casually, idly, is it conceivable? Could we possibly fix this in a compiler plugin? So kind of a Saturday morning I started tinkering around, and not very long afterwards, I had come up with a proof of concept compiler plugin that fixed it. And then a little while after that, I realized that actually it would be much better to do this as a full-blown pull request against the compiler. And I think, how long did that take? That took about a month and a half, maybe 2 months. And we have a fix and it's merged. And I think this is really fascinating because, I mean, this is a big problem. It's been around since 2009. If you look at the ticket on the Scala issue tracker, you can see there's a huge amount of interest in it. I mean, there are like sort of 86 stars on the ticket, where when you think that the average number of tickets stars on a ticket in the Scala issue tracker is basically 0, certainly less than 1. This is something that an enormous number of people are affected by. The pull request itself had a huge amount of interest. Well, why had nobody fixed this problem before? Because it actually turns out that the fix is really small. I mean, it's almost trivial. The initial diff that I had against the standard Scala compiler wasn't a complete solution. It wasn't everything. It wasn't much more of lines of code that actually do something. Not much more than 6 lines. The eventual end result, after lots of feedback from Adrian, from Jason, is about 20 to 30 lines of code, but not the earth-shattering, world-changing change to the Scala compiler that I think many of us had assumed it would have to be. And I think this has sort of made people think again about what our attitude is towards working on the Scala compiler. This is a conversation I had with Runar Bjarnsen on the Shapeless Gitter channel shortly after this. We were both looking at the patch and thinking, well, how could this have held us up for how many years? 6 or 7 years waiting for this when it's only 20 lines of code and not very complicated at that. To make it even worse, Paul Chisano, who's the initiator of Scala Stream FS2, he'd actually proposed the fix in a comment on the ticket. And both Runar and I had read those comments and had thought independently, this is a great idea. Someone should try it, but nobody actually did. And I think there's a lot of reasons why we didn't do that. I think a lot of us had allowed ourselves to become convinced that the Scala compiler codebase is sort of obscure and impenetrable, impossible to work on, impossible to understand. There's only Adrian, only Jason, only Martin could possibly understand anything in the internals of the compiler. And consequently, something like SI2712, which seemed like, I mean, particularly if you look at the description of the ticket is implement higher order unification. It sounds very grandiose, and the paper that's linked to it looks intimidating. And it actually wasn't that hard. And I think if people hadn't felt that it was a difficult place for them to go, they would have actually gone and looked and found that it wasn't actually a tough problem to solve. I'm sure there are many people in this room who could have fixed the problem in exactly the same way that I did in the same amount of time or even quicker. So I think we're now kind of feeling emboldened by this success. I mean, this really is a big deal. I mean, it's kind of one of the, if you were to ask most people involved in type-level projects what are the most important things to look at, it would have been maybe not right at the top, but pretty close to the top of the list of things that are most important for those projects to address. So if that turns out to be such low-hanging fruit, our thoughts now are, well, what else is going to be just similarly low-hanging fruit, or maybe harder, but feasible, something we can actually do. And so we have kind of a shopping list I think. I set myself as the goal for 2016, SI 2716 or bust. So these are my stretch goals, I guess, for the rest of the year, given that I finished early. So one of them is something that's been on the agenda for a long time, is the literal Singleton Type proposal. It was put together initially by George Leontief, and an initial implementation by him, which was then picked up by Adrian Moores, and then parked kind of about a year and a bit ago. So this is something which is very, very useful. I mean, it will be useful for people using shapeless, useful for people using shapeless records. It will eliminate a whole ton of macros in shapeless, and generally make a whole bunch of things that at the moment look a bit sort of weird and scary and intimidating in shapeless code much, much simpler. So I think it's a great thing to have. I've recently picked up Adrian's branch, which is almost there actually, and I've started working on that, and hopefully I will have that in a pull request worthy form shortly. And then ideally that will go into the light Ben Scala compiler. If not, it's the kind of thing that can go into a type-level compiler in a way which is compatible. So it's something that you would be able to compile code with this compiler and expect to be able to mix it at binary level with other code compiled with the vanilla compiler. That's true of actually all of the things I'm going to show you, I think, pretty much. So other things on that list are, I'll just leave it there. So multiple implicit parameter blocks. This is something that Martin's been talking about for Dotty. It's something you find in Agda, in Idris. It's really, really useful. I mean, there are a whole bunch of methods of programming inspired by dependency type programming that this will make enormously easier. Anyone who's used shapeless and ended up wondering, what are all these awks things hanging around? Well, awks is basically a way of encoding around the fact that we don't have multiple implicit parameter blocks. If we had those, all of the awks things would disappear, and suddenly a whole bunch of code written in using shapeless or written in a shapeless style will suddenly begin to look an awful lot clearer and easier to understand and more intuitive. So I think that would be a great thing. Partial type application, again, this is a relatively minor thing. It's mostly syntax, but and you can encode your way around it, but you end up creating all these rather annoying little artifacts of the encoding, which would be nice to be able to get rid of. So one of the other big things that is an issue for people doing lots of type class derivation is the performance of the compiler when compiling recursive implicits, inductive implicit definitions. I have some ideas which I think will massively improve the compile times of those things, which I think can be probably done quite easily. And so that's something I want to look at. And then there are a whole bunch of issues around implicit prioritization, which I think also we can have a look at. So these are all things which are on the type level agenda. These are all things which I think can be done in a way which gets along very, very well with the light Ben Scala compiler, and will allow us to do things more straightforwardly and make simpler code for people to use, and it's all a good thing, I reckon. Core Scala, that's something else that Martin, I think, and Heather was talking about. This is something else that I think we are also very interested in looking at, and that's something that would be interesting if the Scala Center are keen to work on that. I think it's something that type-level people are very keen to work on too, so that'd be great. Right, that's me. Questions, please.
Thank you. I have a very practical question. We are using Scala Z in production. Are there any reasons to switch to Cats? And why to prefer one over another? Thank you.
If it ain't broke, don't fix it. There are a number of technical differences between Cats and Scala Z. Some of which, I think it's fair to say that Cats builds on the experiences of Scala Z heavily. I think lots was learnt during the Scala Z experience, and that has fed into Cats. Cats is obviously younger. Scala Z is obviously established. If you're already using it, there are no immediate technical reasons for you to switch. The thing is, Cats and type level are not just about the technical things. We're about creating an environment where people can come to these ideas, learn them, and make use of them, and in a way which, we have to be honest that the approach that the functional end of the Scala community has approached the rest of the Scala community has not been ideal. And we're trying to fix that. So it's a mixture of reasons. There are some technical ones, there are some non-technical ones. I happen to think that the non-technical ones are at least as important as the technical reasons. That's the best answer I have. Yes?
So with some of the changes that you're proposing making to the Scala compiler, things like 42.type and multiple implicit parameter blocks, these are things that have been talked about or may already exist in Dotty, like 42.type. But some of the forms in which they have been proposed to be implemented in Scala are actually different than how they are in Dotty. Just even surface syntax, like 42.type is different than how singleton types are represented in Dotty. Do you see that as a problem, given that sort of we're moving to Dotty eventually? Are you going to change the way it's proposed to be implemented in Scala? What do you want to do?
So I think the 42.type stuff is actually consistent with the Dotty story now. So the .type bit is optional. So you can just use 42 in type position without a .type, which is great. That was actually my initial objection to the original proposal, because I actually already had a mechanism for using a literal effectively as a type, and I was rather dissatisfied with the idea that I might have to write .type after it to get the same effect with this language extension. So that's gone now, and so I think as far as the literal singleton type stuff is concerned, there is no difference between the Scala proposal, and I'm not sure it's actually in Dotty yet. Is it actually there? It is. Okay. Well, I think it's the same. I think it should be the same. Multiple implicit parameter lists. So I had a proposal on the table for 212, which was a fairly modest extension, which was basically syntactically completely compatible with current Scala. But is a more limited fix, because it basically only allows multiple implicit parameter lists at the end. If you want to have them interspersed, then you have to change syntax somehow. And Dotty has gone for the interspersed model and has changed the syntax. So I think we need to give it some thought and work out what is the best way of. I mean, the thing is, we want to be able to keep as much compatibility between Typelevel Scala and Lightbend Scala as possible, because we want to be able to use it in our day jobs. We don't want it to be something that we're looking forward to in several years' time. We want it to be something we can use tomorrow. So we have to be careful that whatever we do is compatible with what the Lightbend Scala produces, and ideally that we can maybe comfortably mix binaries generated by code compiled by Typelevel and Lightbend Scala. I think that's kind of key. If we can do that, that's fine. So, I mean, we have some flexibility on syntax, but I mean, I think we'll have to see. I mean, more experiments needed, I think, basically. And that, I think, is sort of the general message, is that it's possible to experiment. I mean, this is something that we haven't really thought that was possible. The sort of the build infrastructure for the Scala Compiler is so massively improved now that we have the newer SBT build available for doing this stuff. It is very, very feasible for people to clone the Scala Compiler repo, change it, compile the compiler, and compile some code using the compiler they've just modified. It's really, really easy. It's as easy as many, many other large software projects that people work on all the time. It's nothing. It's a piece of Scala code, a piece of mature, well developed, but like any mature piece of code, it has its rough edges and dark corners and all the rest of it. But it's stuff that people can work on. I really want to encourage people to kind of do more on the Scala compiler. Any more questions? Yes, at the back.
Hello. So for Cats 1.0, like, what's the story on binary compatibility? Or bigger question might be, how would you balance the idea of the stability versus kind of getting the community excited and having the contributor being able to quickly turn things around and add features? Because this kind of relates to the standard library versus the community library, whereas you almost want someone who abandons it slightly so that the other people can basically build on top of it, so it doesn't change for 2 years or something. So I think there's certain benefits to like being semi-abandoned, I think. So I don't know where you stand on this topic. I kind of know, but.
Yeah, it's a tricky question. So I think what we've attempted to do is to, well, so as of a 1.0 release, we expect to be using semantic versioning. We expect to be able to make commitments to maintain binary compatibility within minor releases, in exactly the same way that the Lightbend Scala distribution does with minor releases as well. And I think that's it. I think we have to be able to do that, and that does mean that after 1.0, it means that things will have to slow down a bit, or at least we'll have to be very, very cautious about how we make changes. But that really just speaks in favor of more modularization. I mean, if we have a very, very tight kernel that is ideally as simple as possible, we can treat that as being a very stable base, and then innovate around the edges. I think that's kind of what we have to do. I don't have any complete answers to this. So there may be some other, a bit further out, some answers around catalysts and Crucible, which might be helpful. So I mean, we're looking at things like community builds, but for type level projects. More narrowly than that, I mean, basically, the problem that lots of people have, they have a profile of libraries. Is somebody trying to get me off the stage? Is somebody to tell me not to carry on? Am I completely out of time? I must be. Have I been shut off? Okay, thank you.